they would like connect it to their Hadoop Hive environment and maybe a database, and then they were done and they never changed it. And it was like very static, and they wanted to manage all the configs and Git and stuff like that.
Yeah.
Well, over the past few years, there's been more and more connectors. People want to like set up their connectors. They don't want to have to like, you know, when they set things up, they don't want to have to deal with their like corporate configuration department. Some corporations have that and things like that, to like go and change a property or things like that. So I started looking at this, something like one of the problems I've been looking at recently, and with a bunch of the refactorings we've done over the past few years, I think it's actually much more approachable problem. So I spent a weekend or two trying to hack on it to see if I could get it to work. And I have it to the point where like you can create catalog commands and things like that. I have some code for that, and I've been slowly putting up the changes to get them integrated. Getting the create catalog and adding and removing catalogs is hard, but there's actually an even harder task after that. So the problem is like you create like a catalog for, you know, a Hive system, and then you want to change a property, but you don't want to kill any of those queries. So like, instead of destroying this guy immediately, you wait till all the queries running it have finished, but you also don't want to like stop any new queries from starting. So you need two versions of the same catalog running at the same time. And a bunch of the catalogs just aren't going to support that very well. So we're actually going to have to go through and like tune these individual the connectors to make them work with it, which is just going to take a bunch of time. So I've been working through mainly the framework side of it, not the connector side. So that's going to be some additional follow-up work we're going to need to do.
Is there any of the connectors that seem like they'll just work kind of pretty well out of the box, like that we can start using immediately?
All the ones that are based on JDBC are just going to work, I think so. Yeah.
Nice.
Except for JMX stats.
Except for JMX stats, if they publish them, but I'm not sure if they published them. I haven't looked at them yet. I don't know, when I work on projects like this, I try to do a quick survey of like where the problems are going to be, and then I write them down, and then I ignore them, because otherwise like it's very hard to work on something where it's just like there's a mountain of problems off to the side. It's like I can make progress on one part. So
yeah,
in this next release that's going out tomorrow, Martine, I think is what I heard.
Yeah, tomorrow.
We have this experimental flag that I put in that you only have to set the catalog configuration on the coordinator, and then you don't put it on any of the workers, and the coordinator distributes it to the workers. So that's like one step of this. That's in the next version, but it's experimental. It should work, but I mean, no one's ever run it in production.
Yeah. Yeah, I don't know. Yeah, because that's gonna be the question, right? It's like, and I feel like for me, it was always like I've always seen people trying to use it like a kind of proof of concept. You're trying to build like as you're playing around with Trino, and they're like, locally on your computer. Super nice to be able to like just update things there, and then just like move like essentially like move pretty rapidly, and like, oh, do this through a SQL command rather than having to like restart everything or rejig anything with the files.
Really annoying when you're first setting up your installation to have to like restart everything.
Yeah.
But then once you're like, okay, this is good, I'm going to move to production.
Yeah.
You basically never touch those configs.
Yeah, that's why I think the onboarding particularly is where I think about it a lot, is like, anytime somebody's onboarding and playing around with it, it's like a giant pain. And I feel like I've heard of so many people doing these like little scripts where it just like, crawls out to all the different nodes and then restarts. So cool. And then another one that I've seen a lot is there's all this talk about these C++ vectorized engines. We talked a little bit about this when we were in the Trino community broadcast a while back, but people are still kind of intrigued by this. And Databricks just released Photon, their kind of query engine, I guess. And so I'm wondering, what is your all's reaction, or does anybody have like a particular take on C++ vectorized engines, like the advantages, disadvantages, and then like, you know, will we see that as like kind of a rising trend?
Well, I mean, I want to start with saying that the language is a red herring. You have you can do vectorized processing in C++, in Java, in any other language that has access to lower level primitives.
Yeah, but there's the whole that's like a total marketing thing, right? Like they're very much like it's what everybody is essentially pushing out whenever they talk about Photon now on LinkedIn. So they're like C++, it's, you know, native on the particular hardware, and it's going to be way faster. But is that?
Yeah, those are so it's many of those cases you end up with like you rewrite the system in a new language and then it's faster, and it's not because of the new language, it's because you learn all the experiences from writing the first version, and then you know how to write the second time.
Yeah.
There's a guy I used to work with, I knew from the community, Cameron Purdy, and he worked at Oracle and Sun. And basically what they would do is they would do these competitions with big companies, and they would rewrite a system from C to Java, and then someone would do from Java to C. And so I'm like, which language is faster? And he's like, it's obvious. It's whatever one you wrote it in last. That's always faster because you're better the second or third or fourth time you do it.
Yeah.
And that's the only thing that matters. Nothing else matters.
Gotcha.
Yeah. The reality is that, so if you look at a SQL engine, and if you're looking at real workloads, things that people do in real environments, especially these days, you end up with a lot of JSON data, a lot of unstructured data, a lot of textual data you need to somehow parse through. Querying over that data will require using functions that are not easy to vectorize. I mean, the function implementations themselves, you may be able to do some vectorization, but the overall processing is going to be very hard to vectorize, and sometimes impossible, because like, well, the CPU doesn't have instructions for doing JSON processing. So what's going to happen is that there's only a small part of the query that's going to be able to take advantage of vectorized processing in the CPU, and you've seen the instructions and so on. The rest is not going to benefit from that. So the opportunities for improving performance are going to be very small, because you can only make if you only make something that takes 10% of your processing, let's say you make it twice as fast, you're only saving 5% of your processing time. So that in practice, it's very limited. Of course, if you look at benchmarks that have a set of synthetic queries that, I know, all they do is arithmetic and comparisons and so on, then yeah, of course, you're going to see a much bigger advantage.
Gotcha.
So,
yeah.
Martin, that said, what are the opportunities to do better vectorization in Trino?
I was gonna say, yeah, I was gonna follow with that. No, so we are starting to look into. I mean, actually, we started looking into this end of last year. Starting to look at a new architecture for how the core execution engine works, to be able to take advantage of the fact that data is columnar and is potentially encoded in different ways. Be able to do adaptive kind of runtime dynamic adaptation of the evaluation loops, to be able to perform the cheapest operations first that reduce your data sets the most, and therefore you can save computation. And that's hard to do with when you're doing a row by row process, because you cannot time things at the row level for each of the expressions that you want to evaluate. Once you go towards a vectorized model, you can measure the timings in batches, so you can amortize the cost of timing itself across multiple rows, and then you can make decisions about what to evaluate first, what to evaluate later. And then once if you're start considering, well, you're processing batches of values, say for a comparison or arithmetic operation and so on, then you can either implement those loops in such a way that the VM can auto vectorize that, which it can do in some cases, or for more complicated things where the VM cannot do it on its own, you can take advantage of the new APIs in Java 16 and 17 that allow you to take advantage of SIMD instructions.
So one of the things I remember from the investigations last year was there were some places where you're like, okay, this is like definitely a big win. And there are other places where you go and you try it out and you're like, oh, this isn't a big win. And then you're like, why isn't this a big win? And then you disassemble what Java's spitting out. And you're like, oh, it already figured out and it auto vectorized it. And its auto vectorization, it's pretty darn good. It's not, you know, magic, but that happens in quite a few places where if you write it by hand, you actually do it worse. So that's where I think what Martin was talking about with adaptation is really important, because what is fast for one set of data may not be fast for another. And these things of like, I'm just going to convert everything can end up with overall slower code.
And there are some trade-offs in when you're looking at, let's say you have a complex expression over a set of columns. You're doing arithmetic, you're doing comparisons, and all of that. You have a massive expression that's your filter. Let's say those are operations that you could, in theory, implement in SIMD. If you're going to implement them in batches of rows, so say the batches that we process in Trino, say thousands of rows, 10,000 rows, you're going to have to, especially if you want to be able to adapt the process so that you can evaluate the cheapest filters first and then the most expensive ones, or try to achieve the best selectivity up front, you need to materialize the intermediate results. So you do a comparison, you need to materialize all the booleans that say whether the rows that you process match or not, and then you can use that as a mask to continue to filter or continue to using the remaining expressions that you evaluate. So that materialization can be expensive. Like the CPUs, of course, it can go in L1 and so on, but sometimes it doesn't, and sometimes the CPU can't figure it out, and it's going to end up being more expensive than if you had a very tight loop over a set of values that are somewhat collocated. The CPU can fetch in a reasonable amount of time.
Well, there was that paper from Google about that a couple years ago. Which is that paper?
Tenzing, maybe?
Yeah, but they did exactly that. Extreme Google detail, of course.
Yeah. So there are trade-offs, and it's not a slam dunk. It's not like, oh, I'm going to use MD for everything, and then I'm going to use vectorization where I say I apply a comparison against one column, take the result of that, and then feed it into the next operation for the next column, and so on. That can have a negative impact, and you have to look at every single case. And there are some cases that it's going to be better, some cases going to be worse, and we're going to have to build a system to be able to adapt between the two.
Yeah.
Cool. Yeah, I think you know, that understanding that, and actually that also brings up another question. I know, Martin, I'm trying not to pick on you too much because you have you're not feeling under the weather right now, so I want to be respectful of that. But is there any kind of timeline that we have for like all these performance kind of things? Are they going to be coming down throughout the fall, or when should we start expecting to kind of see those rolling in? Do we have any idea?
Well, we need to get people to start working on those. We have some ideas about things that we want to explore. There's some things that we already did. There's some work that is happening now on improving some of the operators in the engine, aggregations, joins, etc. The more generalized, like evaluation engine refactoring, that's going to take longer, and we still need to do some I guess we'd say research, investigation, prototyping, and so on.
Okay. There's some places to go and like just cherry pick out things, and that's my guess where we'll actually start, and build up more experience with that before we go and build out the general vectorized stuff.
Right.
Okay.
But just to point out, that's not the only area where we're improving performance. And like I said, vectorization is one tool, but we've made a bunch of improvements in a number of operators, like the exchange operators. The aggregation operator is more streamlined. I put up a PR a couple weeks ago for improving the performance of like expressions. It's a complete different implementation. It has nothing to do with vectorization. It's just a faster implementation.
Mm-hmm.
And so if your query uses like intensively, then it should benefit from that.
Nice.
The biggest wins remain better algorithms, better data structures, like big things like, gee, can we cut down the chatty RPCs here and reduce latency? So like those are always the big win. Vectorization for the tight loops will get you at most a 4x, 2 to 4x, depending on how wide your SIMD is. It's like, I'm doing operation on 64-bit things. I can go 512. 512 divided by 64 that's the maximum speed up. You typically don't get something that wide, that full speed up. You get 75% of it. Where you switch an algorithm and you pick the better algorithm and it's 10 times faster. Easy.
Yeah, that makes sense. Okay, I want to take a step back for a bit for anybody who comes back and watches this that's brand new to Trino. So, and I actually just wanted to get the most basic answer to the question. If you all run into like an engineer somewhere, so somebody who does have programming background or maybe has touched a database here and there, how do you answer like the what is Trino question? And this can get, I'll pick on Martin, you take a break with your, I'll pick on David or Eric, whoever wants to answer that one.
There you
go. Eric's like, what was the question?
Sorry. What is Trino? I think in our hearts we all kind of know what Trino is.
I'd hope so. I'd really hope so.
that was the best non-answer possible.
It's really a growing ecosystem, right? Like where we started it is not where it is today, and where it is 4 years from now, I imagine it'll be somewhat different from what we imagine, to be even from this point forward. So it's like, we can see its current capabilities being like a distributed query engine, be able to process what it does, being very performant. But the capabilities are constantly growing. So, like to say what it is, we can only look at what it is right now for the visions that we have. But it's very, I would actually say it's kind of hard to define.
Yeah, it is really hard to define. I'm trying to figure out how to even start to approach that on our getting started page. David, do you want to take a leap at that? Like, how do you tell it to a friend of yours who, isn't familiar with the project?
Yeah, it started off as a project to process data quickly for analysts, so they could, do their jobs more efficiently. And it quickly grew from that was at the Facebook data warehouse. It was focused on the warehouse use case. It was actually even more narrow, right? It was like Hive, right? Or Hadoop, the Hadoop ecosystem. It was very, very specific. Yeah, and it was just an interactive use case. It was only for people, in front of their keyboards typing a query, they want an answer to come back in a couple of minutes type of thing. Yeah. And now it does huge batch workloads. Everything moved to the cloud. So there are a whole bunch of assumptions in the system around this is running on a fixed set of hardware, and now everything's got to be completely dynamic. Now we connect to dozens of data sources. Yeah, it's constantly shifting, and that's one of the things in the project is you always have to be looking at what people actually need, and you have to change your assumptions, because if you don't keep up with what the user base needs, they're going to move on.
Yep. Yeah, exactly.
But you also have to stay focused on what you're good at and what you're I don't know, I'm gonna say core competency, like trying to think of a better way to say that, but like kind of like what the focus of the project. Like we're focused on like SQL being like a really good SQL engine.
Yeah.
And like the things around that. And like, you know, people often like to say, oh, well, what about going in this completely different direction? You're like, well, that's not really what we do. And like, there's other projects that are more focused on that. So like, we need to solve people's problems, but we also have to like stay focused and not just be all over the place.
Yeah. I had somebody ask me just the other day, like, do we have, or are we planning on adding some sort of equivalent to PySpark for Trino, like PyTrino? Or has that ever been something we've considered? And I was pretty sure the answer has been like no, and that's actually like we're kind of taking the polymorphic table functions as kind of a one way to address maybe what people are trying to, certain set of use cases that people are trying to solve with that. But so that's going to be a potential way that we can do that. But has that ever been something like having a whole like kind of Pythonic approach or some other type of common language in the space, using that approach to like define an API around Trino?
So I think polymorphic table functions change everything, like what they're capable of doing.
Yeah.
And I don't know where it's going to go. I would be shocked if we don't have a way of processing Python through them. Like, I just looking at what's in the community and what people are doing, like, I think that will happen, but there's so much possible out of that. Like,
maybe you should explain what polymorphic table functions are.
Yeah, let's do that.
I feel like everyone knows what it is, but I think like,
So a table function, a scalar function produces a single value, a scalar value. A table function, the result of it is an entire table. So like in a from clause, you say like select from table T, you can say select from and then have a function call there, and that can produce an entire table.
Yeah.
The function can also take an entire table as an input, or take an entire subquery as an input. So basically is a function that can process an arbitrary number of rows and produce an arbitrary number of rows.
And it's polymorphic because the output schema, like the set of columns and types it can return, is polymorphic based on the input provided to it.
And by that, David means it's determined. So you put in the query, and then the function itself tells you what the schema of the output is going to be, and it can be different for every set of arguments passed into it.
Yeah.
It isn't a fixed function. So like most functions are like length returns an int, right?
Yeah.
This thing can return anything, and it will tell you what it's going to return. Right.
So I think in the space of what Dan was describing, just to be, because that's kind of abstract, right? Like, like very specifically the type of use case he was thinking about was in the past when you had to have a data source, right? We'd have to represent it as a table, and then we'd have to find some way to squeeze like predicates down to it and whatnot. Right. And so what Dan is basically saying, so with this new function approach, someone can define a function definition that would effectively produce a dynamic table of some sort.
I can give an example of this. So like, if you look in Trino today, there's a catalog called Google Sheets. And the way it works is you go and you say, when someone queries the table foo, you're going to go read data from this URL. And you configure that in your Google Sheets connector. Mm-hmm. Well, I could have a Google Sheets function that's literally go read all the data out of this Google Sheets, and the one argument to that function is the URL. And that would just work. So that's like a different from what we were doing today, where everything has to be literally a table in a catalog.
Yeah, and that function would go look at the Google Sheet, figure out like what are the columns in the Google Sheet.
What are the names on them?
Right, and that would be the output type of that function.
Yeah.
And so depending on like which Google Sheet input you give it, you get a completely different set of outputs each time.
I feel like we should just write this because it would be so much easier to be like, go look at this example.
Yeah.
Than to like try and explain what a polymorphic table function.
The name is bad.
We have examples. Yeah, look.
Nobody knows what a PTF is.
I mean, hardly anyone knows what polymorphism is.
We have a blog post for all this.
Yeah,
experience.
there is a blog post, and actually Cole wrote it, or I wrote a good chunk of it anyways. And then as well, along with Kasia, who wrote the implementation for a lot of this polymorphic table function stuff. And yes, we admit it's like a mouthful, and I don't know, Cole, do you want to, I mean, you're on here, right? Why don't you kind of give your little spiel on it since you're here, and just kind of, you know, let everybody know where you would go, like what kind of resources you would recommend for them to learn about what this is.
Yeah, I mean, I'm a little sad because I think the explanation we got on the fly from Dain and David was better than the explanation I managed to write down after thinking about it for several hours. So at least on a surface level, I'd stick with what they said.
Well, we're recording this, so we'll upload it later and then we can revise.
Yeah. But in any case, you know, I would recommend looking at the TCB, their broadcast. There's a transcript if you just want to read it. There's some motivating examples that are kind of a good way of exploring what you can do. We're going to do more when we actually get these working and we have community members implementing polymorphic table functions. I imagine, you know, we talk about a hypothetical function that executes arbitrary R script. And I mean, not a ton of people are using R, but like if you can execute an arbitrary R script, like you can execute an arbitrary Python script. And we will go out and publicize like, hey, like this new PTF landed, it's super cool, like go out and use it. And we're going to make sure that everyone can go ahead because we want people to use these. These are game changers. My thought is we just need to solve the branding issue. You know, we should just like call them Steve or something like that. You know, like the new Steves are coming to Trino. And
I've literally stopped saying polymorphic table functions and I just say table functions because people actually don't know the difference that like old ones weren't polymorphic and they were like super constrained. And now I'm just like, oh, they're just table functions.
I don't think people care, right? Like they don't need to know that it's polymorphic. It returns a table. Like that doesn't necessarily mean that it has a defined schema. So
I feel like over time, people are going to get more familiar with the function and not necessarily know what it is, kind of like the implementation that it's calling. It's going to be like, oh, that's the thing that calls Python and then generates something that I can use in my from clause. Like they don't even call it table functions or something.
I just want to say that the way we are describing it right now is the way that we're most commonly excited about for it. But I think Martine will testify that it's the reason it's hard to explain in a general format is because it's actually way more powerful than what we described. Like it's like I think Martine has like thought about like ways to like replace the entire execution engine with like PTFs right now. So it's like
that's literally why I think it's a game changer because it isn't just these little things. It's entire new functionality for people to explore, and they're going to come up with stuff none of us have ever thought of.
So yeah, I mean, so don't just think that it is this one thing. It is all of these things, but we're most excited right now in talking about.
It's like the generalization of all these things.
Yep.
Yeah, and there's a couple other examples on the Trino community broadcast episode. Even more in the ANSI SQL document to describe why these things are good. So if you really want to get into the weeds, there's always more to read. But we're going to empower everyone to implement them themselves. We want to make sure that other developers can come in. If there's a use case where a PTF can be leveraged, like go implement it, make it happen, and we'll brag about it later on. You know.
Yeah. So to break the recursion real fast, like if we you know, go back to the first thing we were talking about. So we were talking about, you know, PySpark, now PyTrino. So we think that basically it may be one of these solutions that will take that off of like, you know, people, because right now, you know, a very common way that people will, you know, in the kind of general data engineering space, a lot of times they will use Python to express a lot of these executions. So we're thinking like SQL, but SQL is you know, it's kind of like either using some sort of language like Python or using SQL. And so I think that, you know, kind of if we start using this, what you're kind of suggesting, Dain, is that like this will be something that will totally remove any real need for having to make something other than SQL as a way to kind of address or talk to Trino. Is that right? Or we'll see, I guess.
I wasn't actually making that statement. I was just like, what I'm actually trying to say is like, there are a bunch of interesting new things coming and I'm curious to see how the community explores them.
Okay.
Like where this actually goes and all of that, like I don't know. We'll see over the next 6 months where things go, or the next year.
Cool. Let's pull off to a less Trino focused one. What does everybody do? Particularly, I think we're focused on the creators here. What does everybody do outside of Trino? We'll go around the table and just top hobby that you've been doing recently.
Martine could go first. His is easy.
Oh, hobby.
Cruise ships.
I got a few hobbies. Flying is one of them. I fly small airplanes. I've been doing formation flying.
Nice.
Yeah.
Didn't you do like something like a military formation or something like that you told me about? Like
no, no. What we do is sometimes we get together. So sometimes when a former military member passes away, the family asks for a flyover. So what we do is we get together, we do a flyover, and we do what's called a missing man formation. Just we basically fly over, and then one of the planes in the formation pulls out, signifying the
lost military member. Okay.
Yeah.
Very cool. Yeah, I remember you telling me about that. I didn't know that was actually for an official ceremony. I thought it was just like a ceremonial thing that you learned how to do, but you actually do it for funerals?
Yeah, sometimes we get called for that. Yeah, I mean, someone asked for that, and then this group of pilots, they organize something, and we go and do it.
Oh, that's awesome. Yeah. Fun fact, I used to do funerals for military members and just did the whole the 21 gun salute thing. So so we've both done a lot of military funeral stuff. On to you, Dain.
Great. I play video games. I'll just jump right over that chasm there.
What kind of video games do you play?
So pretty much when I'm playing video games, when I'm isolating from people. So I play single player open world games with no one else around, so I can chill and zone out.
Is it more like you're not playing multiplayer, like
definitely not multiplayer.
No, what I meant to say is
like work.
Or I was gonna say, but do you do like, is it a wild type thing where there's other people playing, but you don't know any of them, or is it?
No, I just play by myself on my console. So,
what's the best one of the last few years that you enjoyed the most?
I really liked the last Far Cry. I thought it was great. I really enjoyed that.
Nice.
It's got the Gus from Breaking Bad is the main villain, and I just love having him in it.
Nice. I always find those games to be too repetitive.
I just play this by myself and I zone out. Like, I'm okay with that.
It's like, you're going to do this mission that looks like one of 4 types.
Sure. I don't care. I'm okay with that.
It's relaxing.
Yeah. That's how I play Diablo. I just like the like hack and slash and just zone out. David, what about you?
I don't know. Watch TV and hang out with my kids. I got 2 girls who are 10 and 13, so yeah, try to do stuff and keep them off their iPads all the time. But
yeah, I was gonna say
that's which is hilarious for you because you just played video games and coded when you were a kid.
Yep, yeah, it's kind of hard to say, you shouldn't sit in front of the computer all day. What was I doing at that age? You know? Yeah, you always try to do better for your kids.
Right. Yeah. Don't what is it? Oh gosh. Don't do what I say. Wait, do what I say, don't say what I okay, I'm messing up the thing, but do as I
say, not as I do.
Not as I do. There you go. Thank you. Cool.
And hypocrite doesn't mean you're wrong.
Eric, how about you?
You know, I've been doing a lot of just relaxing because I just actually finished a huge home remodel, which pulled into the pandemic, and that was like a 5-year.
I was gonna say, didn't that happen when you like first came back to the Trino project like 2 years ago?
Yeah, it was.
Is it actually done now?
It's actually. I mean, it's like, you know, like you think you're done, and then like something breaks, and then they have to come back.
Wow!
Congratulations! It's like, I think we're like, I'm like, no more. So that was kind of a That was half a decade. So I'm like, I didn't want to think about anything. So I'm just.
So your house took half the effort it took to build Trino.
Pretty much.
Oh man.
Okay, half the latency.
Yeah. But recently I've been playing this. I recently picked up Stardew Valley, which is pretty therapeutic. I don't know if you guys heard of it. It's
Is that an iPad game?
It's on iPad. It's on PC. It's on
Tesla.
It's on Tesla. It's pretty. It's really calming.
What is it?
Stardew Valley. It's like a farming simulator, but with like it's with like Nintendo style graphics, you know. So it's like very
nice.
Nice.
Yeah.
All right, I gotta open that.
But it's incredibly well designed. There's a lot more to it than it looks like from the surface. So
Okay, send me the link and I'll add that in the show notes.
Awesome. All right, I'm gonna play that. Probably better than I've played Timberborn, which is like beavers building a city.
Nice.
I've played all of these games. Yeah, Martine linked it on Zoom. But Stardew Valley, I would also recommend. That's also accessible to anyone. You don't need to like be big into video games to enjoy Stardew Valley.
Like I actually play it on my phone, so like if I'm waiting somewhere, I can just pop it out and I can like.
Nice. So it's like a good Farmville. I'm just messing with you.
No, yeah. Well, that was popular. No, this is actually really good. It's actually listed under. I found it because I was looking for like, what are the top games of all time? This was one of them. So.
Oh, nice.
Have you played Factorio?
That seems stressful. That seems really stressful.
Even better than Factorio is Satisfactory.
What's that?
There's an even better version of Factorio called Satisfactory, which takes it 3D and it looks really gorgeous while maintaining the same idea.
Yeah, I feel like when you give someone that many options, you know, like I'm inclined to pull out like a pen and paper and start like doing some math and stuff, and it's just like that's not fun for me. But I feel like I have to do it.
It's actually pretty incredible what people have done with Factorio. You go watch the YouTube videos. People have built bases that self-replicate, and they build on by themselves. Like you can program the whole thing.
Dang.
Oh, so it's basically programming. All right.
It is programming.
We're just trying to find cloaks to pretend like we're not programming and call it fun.
It's like, oh, honey, I'm just playing a video game. It's just like, why are you writing code?
That's why I joined an open source project, was so that I could just be like, oh, honey, this is for open source. This isn't work.
See that thing where the guy built the what was it in what's the one where they mine for things? Minecraft, where they built an entire CPU.
Oh yeah, Martin showed me that a couple years ago. That's insane.
Okay, one day is a computer. It's actually a word processor. You can type, and then it shows up in a big screen. They can copy paste. It has memory. Like
wow.
I was doing that in high school, and it made my electrical engineering courses in college extremely trivial. It's like learning about logic gates was, oh yeah, I've already built a calculator by hand. Like,
it's like cheating.
It really was.
Yeah. What's the equivalent of the torch in the
we just gotta figure out how to get the Minecraft to be self-aware and wonder if there's a creator that's running them from the inside. Okay, how about we hop back to a Trino question? So this one I think is kind of an interesting one that's come up based on like what Bloomberg's been doing. So like there's some work coming in Bloomberg that they might be open sourcing Ranger. So is there like plans, or have we talked about like how we plan to potentially like bring in Ranger or support it, and what have the conversations with Bloomberg been around that so far, or does anybody know?
Well, there's a pull request. They built an extension for Ranger that they've been using. I think they've been using for a year in production, and they just contributed that. There's a pull request open, and we're reviewing that. So
okay,
we'll get in soon.
Okay, cool. And then here's just a generic kind of like This is a good one for all of you. Did you expect Trino was going to be this widely adopted when you created it, or like had any ideas that this would be some potential when you got it, like not when you first started working on the project, I guess, but when you started getting it open sourced and maybe started getting a little bit of traction, like did it make sense that this was going to become, you know, a global project and like a lot of industries would be using it?
So I would say you're like, you think big and bold in the beginning. We're like, oh yeah, we'll make this, it'll be popular, like Postgres, etc. But I don't think we had any idea. Like,
I think it was like, well, we were like, oh, it should be the world's fastest SQL engine, right? It was like the starting premise.
SQL analytics.
SQL analytics.
Yes.
Yeah.
Yeah, it was more aspirational than anything. So
Yeah.
we're building this thing at Facebook. We said, okay, we're going to use it at Facebook. Hopefully other people will find it useful. And we wish it becomes something that everyone else uses, but like when we had no expectation that was going to happen.
I mean, so there was like, you know, oh, we'll use it. Other companies in the Valley, we're going to use it. And then like, yeah, other people adopted it. But like the things that blew me away were like, when Facebook decided they were going to use the engine to compute the financials of the company. That was a pretty scary moment. You're like, how confident are we in the decimal math libraries? And we went and looked at it again. We're like, no, we're pretty confident, but like, that's kind of a scary thought. You don't want a bug that like messes up the finances of a, you know, multi-billion-dollar company.
In the beginning, we had a floating point.
Yeah. So that was perfect for them.
It's a good thing we had a decimals.
Yeah, there's actually a question that just came in that was saying, you know, do any of you have a particular horror and or humorous story that you can relate regarding some very memorable moment during the first few years of developing Trino? I think potential horror stories or something maybe that went out to open source, or I don't know.
Well, the one I remember the most is so this is the 10th anniversary of when we started. And around December or something like that, we went and showed our first version to our boss. And we were like,
I mentioned that one too. Yeah.
We're like, this is amazing. Look at all this stuff. And he's like, this is great. You guys made good progress, you know? And then we left the meeting and we're like, God, that stuff is terrible. And we deleted almost all the code and started over again. Because it was bad. It was really bad.
Well, so was that kind of your iteration, like getting the first one out there and learning how not to do it and then restarting it? Is that based on what you guys were talking about before?
Well, I mean, when we started, we had no idea how to build a query engine. I mean, we had experience building distributed systems, languages, compilers, like toy databases, but not like a full-blown query engine. And so what we did when we started was we looked at a bunch of research papers to try to figure out, okay, how are people doing this? Because there's you can go and open Oracle and see how it's implemented, right?
Yeah.
And you can look at Postgres and other systems, but they're quite complicated. So
and their transaction processing database. There was
exactly. There were any. I mean, Hive at the time was horrible, so that wasn't a good example to start with.
It's still horrible.
Yeah.
And does all that code in Postgres, like, did you guys try to look at it and did you try to get some sort of inspiration from it, like thinking, oh, if you know, look at it and then it was kind of overlapping and mixed with the transactional stuff and the IO stuff, it's just all kind of hard to separate it apart since we're only trying to do the query engine portion?
I did not at the time, but I did look at the optimizer parts later, a couple of years later, but it was, I mean, it's clear it was something that evolved over many years, and like in some cases there's no rhyme or reason to things. Like it's not something that was designed from the ground up to look exactly like it does. It's a like natural evolution of a system. So no, but we looked at a bunch of research papers, tried to figure out how people were doing it, and none of the papers are complete. Like they only talk about one aspect of some system. So if you try to assemble things from those parts, you're not going to be very successful. So we had to extrapolate in our experiments and thinking. And in the first 6 months, so we started writing. The first commit was August 8th. in 2012.
Mhm.
We had the system in production by January 2013, so that was less than 6 months. And in that period, we wrote the engine 3 times.
Wow.
So that gives you an idea of how much Trino was. And
there
we
was
tried a
that-
couple of ideas.
There was that point where we actually found the source code for one of the papers we were reading. And this was kind of after, like, we had tried to implement, we're like, this doesn't work. We're like, oh, here's the code. And we started reading it. And the code was super buggy and deadlocked, like, all the time. It basically only ran the exact query that, like, the researcher wanted. It actually run queries, like, you hand wrote the exact thing you want. And we're just like, oh, so this is just totally broken. I don't even know why we're, like, starting here. Like, the idea literally actually doesn't work. It just deadlocks.
The thing I found really striking in that initial phase is that you read a lot of the papers, and a lot of the papers are, I would say, highly aspirational.
Yeah.
In the sense that, like, they'll describe a basic strategy, and then they'll be like, and here are all of the dozen other, heuristics you can apply to optimize for this shape and that shape and that shape, and adaptively swap it in. So when we're building it, I remember we're like, oh, we're going to be super adaptive, and all of these things we're going to combine it, and it's going to be like super amazing. And then you look at the first, I think I want to say, like, even today, even like the first 5, even up until today, like the engine is really built around like core fundamentals just running well in general, and like all of those adaptive things that we had talked about, we still want to do them, but they're like, we still have to do them, right? So we've gotten all of this away from the very beginning without like all of these, the other things that these papers love to talk about is like, oh, in this case you could have applied this and made that better, but it's like really you nail the fundamentals, and then the system, the rest of the system kind of grows around that.
Well, in real life use cases, like you have to hit this like huge range of things. And like people are like, oh, they want to run like a sum query on an integer, and they want that to be like super fast. And then they're going to process like a 50 megabyte JSON blob, and that has to work without like running out of memory. And because you're like, okay, if I'm going to do like a sum, right, I want to process like 1,000 values at once. But now if I have like a 50 megabyte JSON blob and I have 1,000 of them, like that's way too big. So you've got to make the system actually work like for all those cases.
Yeah.
Yeah, and just if you think about like the complexity of how some of these things, like I remember we were looking at like the C-store paper, right?
Oh, yeah.
And they're like, oh yeah, in some cases we'll rewire like the like the planes in this shape, and then when it adapts, we'll rewire it this way. And it's like you think about it's like, okay, theoretically, yeah, that makes sense, but practically, if you're actually trying to implement that and then maintain a system that does all of these things, like how the heck are you going to possibly like debug this thing, and like is it, if it does the wrong thing, like what how do people feel about that, right? It's like it's
well, there's the Vertica. Vertica was based on C-store, it's like the commercialization. There's a paper like Vertica 10 years later where they talk about like basically everything they did in C-store like didn't actually work when they went to build the production version of it, like everything they did differently.
Of course, this was like after we were like,
oh yeah.
So I remember having these conversations with Martine. So in the early days, we would debate. I would say this is an optimizer problem, and he'd be like, this is an execution problem. You need to be adaptive. Actually, we still have this debate to this day. And like, I clearly remember these conversations about these like adaptation things. And I'd be like, okay, so to do that, to make the adaptation, first thing we need to do is to stop everything. Then we need to figure out where the data is. Then we need to reorganize it. And then we need to, and I'm like, generally when you get to the second or third, and then we need to, like, it's so infinitely complex, like it's never gonna happen, right?
Yeah.
And we have put in a bunch of these optimizations, but the adaptive things, but they're like one step. They're like
predictable.
This thing that Dave was talking about is like, we look at the size of the rows or the last page we produced, and based on that, we estimate how many should be in the next one. And if it's too big, what we do is we stop the processing, we throw everything away, and we start over with a smaller thing. And that's the adaptation. And it works amazingly well. And they're all throughout the engine, but there are these little tiny things. They're not like, and then we reorganize the whole thing.
Yeah, I feel like there's a quote that's like, the first step to solving any problem is like, you got to define the universe. And I feel like that's like, I feel like that's constantly the problem with these, like very high flung, like theoretical approaches to solving these, very abstract problems that may or may not, like are very beneficial, but getting to those, you have to even actually just make the foundation work. And I feel like that's what a lot of these first 10 years seem to have been the focus on, has been actually just getting this foundational of like every single use case under the sun that actually people care about. And we're still in that process, right? So
the number one thing is, the most important thing we did was ship after 6 months.
Yeah.
Nothing focuses you more than having a system in production and have people using it. And then like all this theoretical stuff is just like bogus. You ain't got time for it. You can see how people are using it. You know how to make it better.
Yeah.
Like, yeah.
Yeah. And after we launched in production, we kept deploying to the clusters like every week, every couple of weeks, and it was on constant pace. And we tried to maintain it up to this day in terms of releases. That's how we were iterative and incremental in everything we've done.
Yeah, there was an existing system at Facebook that ran reports. There were like 20,000 reports, and we had to like end of life the system and move everything over. And so we did like this big migration, and like you find all these actual issues once like you run this real workload on it. Yeah. And that was just like iterate through it, like, oh, we need to implement this thing, and now we need this thing, and now we need this thing. And like, well, at the end of that, now you actually have a pretty useful working system that like you wouldn't have predicted if you just tried to do it from scratch.
Yeah. And then you also reached out to like Airbnb and a whole bunch of other companies, and then pulled in their workloads as well.
Oh, yeah.
So.
I mean, in the beginning, everything, once you're rolled out and you have users, everything you need to do is super obvious. Like, it's really, really easy to see what you need to do. It's actually really easy to prioritize. It isn't until like you get like a ways into that where like actually people aren't complaining that much anymore. And that's where I think expanding out beyond the Facebook use cases, because like a bunch of the problems that everyone else was having, like we just didn't have at Facebook because we didn't use those other systems. We didn't do things that way. I think that's where it got really good.
Yeah.
It's another fun story from when we first launched, or we got the first version running in a cluster at Facebook. So we deployed Presto to a cluster. I think it was like 30 machines, or something like that. 34 machines. It was one rack of machines.
We asked for test. We asked for a test environment.
A test environment,
They give us a tiny test environment, see how it goes. So they gave us a rack of 30 machines. That was the smallest thing they could give us.
So we deployed. We had the first version running. We deployed it. We went into a meeting with. It was our team meeting with our manager. And we said, hey, we have the system running. We want to show you some queries. So we started running some, it was simple sums and filters and simple aggregation and so on. And everything running perfectly, was running super fast. Then we finished the meeting. We went back to our desks and we're trying to get back to the cluster.
We went to lunch and celebrated, remember?
Oh, yeah, we went to lunch, yeah. Then we went back, we went back to our desks and okay, we're just trying to log into the machines and or I know keep working on that system. We couldn't log into the machines. We couldn't even SSH to the machines.
So ping the machines.
We couldn't ping the machines. So we're trying to figure out what's going on. So we started talking to the network people. There's a network operations team, network engineering team, etc. And eventually we found someone that said. They told us, "Oh we had to shut down your cluster. You guys caused a brownout on the network, and you took down the payment system for Facebook."
Thank you, guys. That was the anecdote I was looking for, because I had very similar in the .com era where it turned out our CEO didn't pay the hosting bill at 3 a.m. and we went dark, and so that was that's very similar.
Yeah. So what happened was that there was a flaw in the design of the network architecture of Facebook at the time, where if you have all the traffic flowing into one rack and the top of rack switch was saturated coming into the rack, it would cause a backup on every flow going through the downstream switches of that rack, regardless of whether you were going to. So basically, by saturating your top of rack switch, you cause every other pairwise communication to slow down in the data center.
Like the whole data center.
Yeah, in the whole data center. So yeah, it was Presto was the first system that was able to pull data at such a volume so quickly that ran into that problem.
Wasn't it that the original system wasn't actually pulling all the data or something? Like you found out that the original system.
That's another. I can tell that story too. So that's another story. So the system that David was talking about that we were replacing, so it was a system for. So we had Hive as the batch engine. There was another system that tried to replace Hive for the interactive use cases, and it wasn't being maintained. What? Sorry.
Peregrine. Yeah.
Okay. Yeah, Peregrine is called. So it wasn't being maintained. It was written in C. It wasn't being maintained. It wasn't scaling. The architecture wasn't conducive to making the kinds of changes we need to do, like for example, to add joins and more complicated capabilities. And so that's why we started building Presto. And we had to replace that system. And of course, we had people that were using that system, and we had to convince them to move to Presto. So we did a bunch of work to make sure that Presto was faster, that it had all the features that other system had. We migrated those 20,000 reports that used to run in the old system. They run faster and better in Presto by the time we were done. We had almost all the users migrated to Presto, and they were happy with it. And we're hearing from them they were happy with, but there were some stragglers. So we're trying to find out, okay, why do these people not want to migrate? And there was one guy that was saying, well, I can migrate to Presto. Like I run this query and it runs in 5 minutes in Peregrine. When I run it in Presto, it takes 30 minutes. This is unacceptable. I cannot. This system sucks. I won't use it. So we're like, well, we went back and trying to figure out what happened. Like why how is it possible that this is 6 times slower than Peregrine? We spent a bunch of time optimizing things. We knew it was faster. We had measure things, we have benchmark things. So we started looking at the code for Peregrine, and then we realized there was a place where it said, if the query had been running for more than 5 minutes, stop the query and return whatever results the query produced at that point.
Yeah.
Wasn't this actually feeding reports to like Mark Zuckerberg or something?
Yeah.
It had a similar feature for aggregation, where if there were more than like 10,000 groups, it would just stop adding more groups to your aggregation.
It was based on memory. Yeah, if the aggregation used more than 16 megabytes, it would stop aggregating and return whatever it had at that point.
Yeah. That's how you make a performance system.
Right there. And it did all of this silently. So all these people thought that they were like getting correct results, and you're like, this is slow because you're getting answers.
Well, what was the reaction? What was that person's reaction that you were talking to when they found that out? Was she just like totally blown?
I think they were very apologetic after that.
All right. A core tenet was like it always had to return correct results. Yeah. Like any correctness issue was like a #1 bug.
Yeah.
Well, we didn't quite have the turnout that we were anticipating, but thanks so much, Greg, for being our #1 fan along with Neville. Neville Lee, if you're hanging out back there still, thanks for joining us. And I'm sure a lot of people are going to catch this, a lot of these hilarious stories. Oh, yeah, thanks. Neville's there. He just replied. Thanks for hanging out with us, Neville. And yeah, so we'll, I'm wanting to know if anybody who's watching this recording, who actually watched through to the end here, let us know if like these interactive meetups or something you all want to do. Greg, what do you think? Was this fun, and would you join more of these if we're just sitting around kind of bantering, hanging out?
Certainly. I go back probably, unfortunately, 40 plus years, and even at Ingress and stuff in the early days, and Stonebreaker company. So I'm into especially all the good work that Trino and Presto and these guys have done on the optimizers and stuff. I've been doing that for decades myself and been a fan. So I can geek out on this stuff all day.
Nice. Cool. Yeah, we're hoping to do more of these. Like we've traditionally done meetups in kind of a like presentation style, and you can kind of type in, but I'm hoping to see if these have any traction here. And so yeah, definitely we'll be trying to pick up on more of these. Does anybody have any kind of like closing remarks and kind of hoorahs that they want to say about the 10 years in this, and what's the next 10 years going to look like, maybe as a closer? Predictions. Where are we going to be in 10 years, Dain?
Where are we going to be in 10 years? I don't know. To the moon. So
is Trino going to run on one of the rovers?
No. I mean, I'm super bullish about where it's going to go. Like what Trino's doing, I think, is only getting better. I mean, when we started this thing, like our conversation was, it takes 10 years to build an okay database. I think we did it in less than 10 years. I think we're a pretty good database, but we can be an amazing, like one of the best ever in the next 10 years. There's so much cool stuff that's coming through. Like, I feel like we're actually accelerating, not slowing down. Like, which is, I would have not have guessed. My guess is like, you build up, you get like your general, and then you're just kind of iterating away. But like, you see like the amazing stuff that's coming in with like merge and materialized views and table functions and the new function system and like all this stuff. Like, I feel like it's getting more and more awesome, like, which is impressive.
I mean, I'm also really excited about like the stuff we're working on at Starburst with Galaxy. It's like we're doing all this great work in Trino open source, but also like, because like Galaxy is a product that like people can just use, like we're able to deliver like all these features that like we just can't. We wish we could do an open source, but like it's just far too complicated because like everyone has to run it themselves, and it's like, oh, do I have like a MySQL or a Postgres, or am I running on-prem or running in the cloud? Which cloud? Like, there's just so many features that like we wish we could ship, that like we build kind of versions of these at Facebook where it's like we just have one platform and one like system support that like we can actually deliver to people like through a hosted service that like is awesome for people who want to use that.
Yeah. In current day, I feel like people feel like that's, Athena, but people are like not wanting to be totally restricted to AWS anymore. Plus the other thing is like, there's clearly a lot of stuff that, Athena's like kind of not currently keeping up with on the Trino side. And it doesn't really keep as close to the open source project as I think Starburst does. So I don't know, there's a lot, that's where I think, people are from a adoption standpoint, that's where that's going to be kind of like, eye-opening for a lot of people, is to see like that as the kind of easy button route for open source Trino, essentially.
Yeah, like we love open source. Like, we're always working on the open source project. We want it to be awesome. We want it to be around forever. But like, it feels like Galaxy, like we're actually delivering like the product that like we've always wanted like people to be able to use.
I was super happy when Athena launched, like, because I had friends who like wanted to use the stuff written and just couldn't work on getting it set up. And now I'm super happy that like we can go and build out a much bigger thing at Starburst.
Yep.
Yeah, because now like we can say like, oh, you want to use Trino? It's like one click, go sign up here, and like you have it. And like, because I mean, we build this software because we want people to use it.
Yes.
And like this is like now with Galaxy that we're working on, like we can just make it super easy for everybody.
Well, like Docker containers like that. Yeah, it was a game changer. Like, I love this stuff. So like, I want more and more and more people to use it. Like, yeah,
I think that's going to happen faster than we know, and I think it's just going to be a matter of like people kind of understanding, how. I think people understanding that crucial question that we're still trying to figure out how to answer is, what is Trino? And I think it's a hard question to answer because we are evolving so quickly. But I think that as we make that a lot clearer, and people kind of get the the gist of what we're trying to solve, the kind of issues that we are solving and are planning on solving, and how we're planning on solving it, and that's going to become a lot more easier for people to jump on board. So cool. Well, thanks for hanging out with us, everybody. Greg, obviously, all of you who have created Trino / been there since beginning. Cole, Manfred, and Hangout lurking in the background, and Neville. Thanks everybody who is going to be joining us and hanging out with us and watching through on this YouTube later. Definitely reach out if you're kind of interested in getting involved in the project. We have trino.io/Slack if you want to come join us and hang out with our. Now we're hanging out at, where are we at? Hold on, 7,534 strong on the Slack channel. So and we're growing just drastically. I think we were somewhere around the 4,000s last year. So that's almost doubling it in a year. So we're definitely taking off and hope to see you all there. Take care and have a great rest of your night, everybody.